In this lesson, we're going to talk about half-angle formulas. And to start, let's review the double-angle formulas. So here's what we learned in the last lesson for sine and cosine. And we are trying to find out a formula for sine of half of an angle. So let's look at and we know we need to talk about, we need a relation between two angles where one angle is half of the other angle. So if we look at this formula, where do we see half of an angle? So we know that this is twice an angle. Well, if this is twice theta, we know that theta is half of 2 theta. So we know that that is half of that. And that means we could rewrite it like this. Call that A. And that'll be half of A. If A equals 2 theta, then theta is half of A. And now what we have to do is isolate this sine of A over 2, and then we'll end up with that. So let's go and we'll divide by -2. And then, since we're dividing by a negative, we normally write it like this. And then we can do square root. And there's the formula for sine of half of an angle. So let's write that up here. Sine of half theta is positive or negative 1 minus cosine theta over 2. And we can do the same thing with to get a formula for cosine, but we won't use this formula. Let's use this version of the double angle formula. So we'll start with that cosine 2 theta. So I'm just using that version of the double angle for cosine. And then we see that theta is half of 2 theta. So why don't we just call that beta, and that'll be half of beta. If theta is half of 2 theta, then we could say that beta over 2 is half of beta. And now let's do the same thing. We'll isolate this and solve for cosine beta over 2. So we're going to go +1. We're going to divide by 2. And then square root. So we get cosine +1 over 2. And that's what we get up here, positive or negative. And let's just go ahead and write it as 1 plus cosine, just so that it's easier to memorize. So look at how similar these are. They just differ by the operation. So if we can just memorize that sine has a subtraction and cosine has an addition, they'll be easy to memorize. And if we just put this divided by that, we'll end up with the formula for tangent. So when I divide this by that, the 2's cancel, and we just get positive or negative 1 minus cosine theta over 1 plus cosine theta. find the exact value using the half angle, and we're going to have cosine, evaluate cosine of 157.5 degrees, and try that. So 157.5 is half of 315. We know that 2 times 157 equals 315. So we want to find cosine of that. That means that if we have cosine of 157.5 is the same as cosine of 315 over 2. We want to find cosine of 157.5. We know that there's that relation. We want to find this. Let's rewrite it as a half, half of the angle. And then we can just use the formula for cosine, positive or negative. And cosine is 1 plus cosine of 315. It's a positive or negative, so we need to look at what quadrant 157 is in, and that'll tell us what cosine, whether cosine is positive or negative. So here's 180, 157 is there, so we know cosine is negative. We know we need to take the negative. Alright, and then we have to evaluate cosine of 315, and 315 is a 45, has a reference angle of 45 degrees. So that means it's a 1 radical 2, and we know that the cosine is going to be 1 over radical 2. Alright, so we know it's negative. It'll be a negative 1 plus 1 over radical 2 over 2. And let's rewrite it as 1/2 plus 1 over 2 radical 2. Just putting the 2 under each of those. Now let's get a common denominator. Yeah, common denominator. So this will be a radical 2 plus 1 over 2 radical 2. Because I'm going to multiply by radical 2 over radical 2 here. Radical 2 over radical 2. And then let's rationalize that denominator by multiplying by radical 2 over radical 2. So that'll be 2 plus radical 2 over 2 times 2. And that'll be 2 plus radical 2 over 4, which could be written as 2 plus radical 2 over 2 because the radical 4 comes out as a 2. Alright, and try that one using a half angle formula. Pause the video. We know that twice 75 is 150, and we want to find sine of 75. Another way to write 75 is 150 over 2. So now we have written it as a half angle, and then we can just write out the formula for sine 1 minus cosine 150 over 2. All right, it's positive or negative, so we have to find out what quadrant, what's cosine going to be at 150. And so we look at 150, it's over there. We have negative cosine, and that means cosine is going to be negative. No, I'm sorry. Let's look at 75. We're not looking at 150. We're going to look at 75 is there. So we're trying to find out the sine, S-I-G-N, of S-I-N-E. What sign should we use here? If we're looking at a 75-degree angle, we see that S-I-N-E, the sign, is positive. So we're going to take the positive there. Cosine. Now we have to evaluate cosine 150, so we can look at 150. That's a 30-degree angle, so that'll be a 1, 2, radical 3. And we want the cosine of that, so that's going to be negative radical 3 over 2. Plus radical 3 over 4. And we're going to get a common denominator. That'll be a 2 over 4. So I multiplied by 2 over 2 to get 2 over 4. And then we have 2 plus radical 3 over 4. The denominator, you can take the square root of the denominator and bring it out. And we can leave it like that. Let's try one more. So go ahead and do the same strategy for tangent of 165. Pause the video. So we know that 165 is half of 330. We want to find tangent of 165, but let's rewrite it as the tangent of 330 over 2, because then we can use the formula for tangent, and that is positive or negative 1 minus cosine 330, 1 plus cosine 330. We need to know whether it's going to be positive or negative. So 165, let's see where that is. 165 is there, and tangent is negative. So we want to make sure we use the negative here. We have to evaluate cosine of 330. 330 makes a 30-degree angle because that's 360, so that'll be 330 there. A 30-degree angle has the 1, 2, radical 3. So the cosine is radical 3 over 2. We will have negative 1 minus radical 3 over 2, 1 plus radical 3 over 2. And let's get a common denominator in the numerator. So that'll be a 2 over 2 and a 2 over 2. So it's 2 minus radical 3 over 2. And here we have 2 plus radical 3 over 2. So this was 2 over 2, and that's 2 over 2. That's how we got that. Then we can multiply the numerator by the reciprocal of the denominator, and we'll end up with And there's some more simplifying to do there, but let's go ahead and stop on that one. We won't simplify it anymore. We'll go on to another problem. Alright, so just like with a double angle, when we had 2 theta and a theta mixed in the same problem, here we have an x over 2 mixed in with an x, so these need to be the same. We have to rewrite this to just be an x, or if we could rewrite these as to be x over 2. So let's go ahead and try that. We see sine squared of x over 2, so let's think of how can we substitute. And we know that sine of x over 2 is that. That's going to work out nicely because we have it squared. So if we did square that and we squared that, we know that sine of x over 2 can be sine squared of x over 2 can be replaced with 1 minus cosine over 2, so that this thing here, this factor, sine squared, is going to be replaced by 1 minus cosine. We can cancel that. 1 minus cosine plus cosine. So here we're going to have a 1. So what angle has a y value of 0 and a radius of 1? The y value of 0 is there. So we get 0 and pi. Alright, so we need to change the x over 2 to be an x. So pause the video and try that one. We have a formula for cosine of x over 2, and we know that's going to be 1 plus cosine over 2. We want to have a formula for cosine squared, so we can square it. And we know that this is going to be 1 plus cosine over 2. Wherever we see cosine squared x over 2, we'll replace it with 1 plus cosine over 2. So this is going to be 1 plus cosine over 2. Now we have the problem of having different trig functions, so let's rewrite this in terms of cosine using a Pythagorean identity. So sine squared is 1 minus cosine squared. Then we go minus 1, so that's 0. Add cosine squared, now we have that. factor cosine equals 0 over 1, and that means we need an angle with an x value of 0. The x value of 0 is there, there. And then here we want an x value of negative 1. Well, that's there. So we get pi over 2, pi, and 3 pi over 2 as the solutions. And that's it for today.